All right. So for our next lesson, we're going to talk about derivatives for trig functions. In case you haven't ever learned about trig functions and their different identities, these are all the identities. So some of the most important ones are, let me highlight a couple of these. Tangent being sine over cosine is really important. And then sine squared plus cosine squared equaling 1 is another really important one. Let's see. Yeah, I'd say those are like the main ones. Those are like the most important ones that you should probably memorize. And then other things just to like be aware of. You have sine and cosine, and then you also have secant and cosecant. Those are kind of like the mirror opposites of them. So sine goes with cosecant, whereas cosine goes with secant. It's kind of weird. The one that sine gets a co, and then the one that has co doesn't get the co. These are a lot to remember, so I wouldn't necessarily bother remembering them. I would just take a screenshot and just keep this ready so you can always refer to it. Let's see. Okay, these are down here. These like the main derivatives. And the most important derivatives here, just know that when you take the derivative of sine, it goes directly to cosine. And then when you go back and take the derivative of cosine, oddly, it goes to negative sine. Let's see what else. Okay, I think also knowing the derivative of tangent would be important. Just knowing the derivative of sine, cosine, and tangent. So tangent becomes secant squared. The other ones, they're pretty funky, so I wouldn't try to memorize them unless you need to for your test, but you can always refer back to here. Down here, these guys are the inverse derivatives. These are really complicated, so I would just have these for reference. Yeah, so taking the derivative of trig functions is mostly about just like knowing what to substitute it for. We're not going to do so much work where we did before, where it's like if you have a polynomial and you have like x3 plus that, we're not going to be doing the work of like bringing the 3 power down and making it x squared. We're not doing that. For this, it's just like, okay, tangent, the derivative of that is this. We're just substituting. So you either memorize it or you just have it all referred or to reference. So let's just jump in, do a couple of these example problems. Basically, all these problems are going to use either like the quotient rule, product rule, chain rule, but we're just going to be using trig functions instead of like x squared, things like that. So for the first example, we have 4 sine 3 theta. And for this, we're going to use the chain rule because we have an inside function and an outside function. So we're going to consider 3 theta to be the inside function, and then 4 sine to be the outside function. So basically what you do with that is you take the derivative of 4 sine and then the derivative of 3 theta. So this is like the chain, which is like the inside part. So the derivative of 4 sine, think about sine as being the x. So I'm going to rewrite this as 4x times 3x. So that looks a little bit more familiar, right? If you were to take the derivative of 4x, it would be 4, right? So when we take the derivative of 4 sine, sine is going to be replaced by x in our head, because 4 sine is not what we're taking the derivative of. We're just taking the derivative of sine. So, right, before we're doing the derivative of 4x, the 4 stays the same. The only thing that you do is change the x. So what is the derivative of sine? The derivative of sine is cosine. So instead, you just replace the sine with cosine. And then the value behind it's going to be u, which is what stands for the 3 theta, or the inside part. And then once you have that, we're going to take the derivative of 3 theta. And then that's going to become 3. So the tricky part here, I guess like one thing I like to point out is this. When you see this part, it's asking us for the derivative in terms of theta. So it's d over f, or derivative of the function over the derivative of theta. And so we're splitting up into 2 parts where we take the derivative of f in terms of u, and then we take the derivative of u in terms of theta. And this is true because if you have du on the bottom and du on the top, they cancel out and you get df over d theta. And what this is really saying is you're taking the derivative of the f function, but what you are taking the derivative of is the bottom part, the theta. So theta, this theta is like the x. So in the first part, we're taking the derivative in terms of u. So this part, which means that u is like the x. So that's why we're doing 4 sine u becomes 4 cosine u. And then for the second part, the chain, we're doing the derivative in terms of theta. So 3 theta is like the same thing as saying 3x. So we take the derivative of that. Theta is like the variable x. So it goes away. It just becomes 3. Like you can literally imagine theta as just being x. If you take the derivative of 3x, it's 3. Okay. And then when you combine these, you get 12 cosine u. And then when you replace u for 3 theta, it's going to be 12 cosine 3 theta. Cool. All right, let's try another example. We've got 6 examples total. So this should give you a good understanding of all this stuff. Okay, so we're going to do 3 cosine cubed. So imagine all this is like saying 2x cubed. For this one, it looks like we're going to use the chain rule. So we've got like the outside function, which is this big thing, and then we have the inside part. So we would do, we're going to figure out the derivative of the main part, 2u. And instead for u, we're going to make u stand for this inside. So we're going to rewrite this equation as 2u cubed and make u stand for cosine. And then cosine is going to be that last bit that we take the derivative of. It's like the chain. So first, we're going to take the derivative of this, 2u cubed. You bring down the power of 3, it's going to be 3 times 2, and you get 6. And then your new power for u is going to be 2, 1 less than 3, right? So that's this part. Next, we're going to take the derivative of cosine. And if you remember, the derivative of cosine is equal to negative sine. So that's this part. And then when you combine them, you get negative 6u squared sine. And then when you substitute back in for u, cosine, you're going to get negative 6 cosine squared theta sine theta. Okay, let's do another one. This is going to be the product rule. because we're multiplying this guy times this guy. So we're going to call secant f, and we're going to call tangent theta. And if you remember the product rule, you're basically going to do f prime of g plus g prime of f, or fig plus gif. So let's figure out what's the derivative for secant. And let's figure out the derivative for tangent. That's going to give us f prime and g prime. So the derivative for secant is going to be secant theta tangent theta. And then our derivative for tangent is going to be, let's see, it's going to be secant squared. Okay. So now that we know what the f prime and g prime are, we can write out this equation. So we can now say that it's this. We just basically just did this part. The derivative of secant, that's this part for f prime. And then the derivative of tangent, that's this part for g prime. We have that. So now we can write this equation out. So it's going to be tangent times secant theta tangent theta, and then secant times secant squared. And then when you combine that, this one has 2 tangents and this one has 3 secants. So we're going to say this is tangent squared secant plus secant cubed. Okay. All right, this one's going to be a quotient rule because we have f over g. So we're going to put it into this format. So in order to do that, we're going to say cosine f prime times g minus g prime times f over g squared. G is cosine, so that's going to be cosine squared on the bottom. G is cosine, and then f prime is going to be the derivative of this top part, and then we're going to have f, which is the original, and then g prime, which is the derivative of cosine. So let's figure out the derivative of 1 plus sine. 1 plus sine, well, the derivative of 1 is going to be 0 because it's a constant, and then the derivative of sine is going to be cosine. So that's how you get this. Now let's figure out this part. Derivative of cosine is equal to negative sine. Derivative of cosine is negative sine. So that's how we get negative sine. So then let's combine this. Cosine times 0 is 0. So ignore that. And then you do cosine times cosine, you get cosine squared. And then if you do minus 1 times sine, you get minus sine. And then minus sine times sine, negative sine, you get negative sine. So minus. And if you distribute this, you're going to have cosine squared plus sine squared. And if you remember, cosine squared plus sine squared is equal to 1. So all of this is going to be rewritten as 1 plus sine theta. And the bottom stays the same. It's going to be cosine theta, cosine squared. Okay. This next one, we're going to use a chain rule because we have a big part and we have something on the inside. So we're going to take the derivative of 4. 4 tangent inverse. Okay, so that since it's a tangent inverse, it's going to be one of those like 1 plus u squares or like square roots. Those are all those really like messy identities. So just go back to that first page. Let's figure out tangent inverse is going to be this. So 1 over 1 plus u squared, or 1 plus x squared. All right, well, I guess we're done with that one.